So today we'll be looking at functions and introduction to functions. So we'll be looking at all the functions that we see in the methods course, what their order are, the key features, range and domain, and whether it's a relationship or a function. So without further ado, we're going to look at our linear function here. So linear function, what is that? A linear function is basically my standard polynomial. Now polynomial is anything in the form of, y is equal to ax, to the n plus bx, the n take 1 plus da da da. So we know that y is equal to x is going to be part of this, where n is our highest power. The order is always the highest power. The highest power here, x is to the power of 1, therefore the order is 1. Okay, so for a linear function, what are the key features? Well, you've got your y-intercept. So y-intercept typically starts off at 0, 0, and we have our gradient. Our gradients rise over run. So gradients rise over run. And we've got our y-intercept, which is typically, plus c, mx plus c. In fact, I'll write that underneath. Y is equal to mx plus c. Gradient's equal to rise over run. The other way of saying that is y2 take y1 over x2 take x1. And there we go. We can also have a look at the behavior as well. So what happens as x goes to positive infinity, or we can just write infinity, well, as x gets bigger and bigger and bigger, we can see the y, so our value, so x is 10, it's there, x is 11, it's getting bigger, 12, it's getting bigger. So therefore we say y approaches positive infinity. When x is going to negative infinity, we say that y is approaching negative infinity. Now, if our gradient swaps, we can see that this will change, and we'll look at that in a different video. So we've done our behavior, we've done our key features. Let's look at range and domain. So we can see x. Is there any values where x can't exist? Well, x can be negative 10, negative 5, 5, 10, up to infinity, and down to negative infinity. Therefore, we say x is all real numbers. And y, well, y can be any value, so be from negative infinity to infinity. It doesn't matter if these swap around. If this gets swapped, then it'll be fine. The only case in which y isn't all reals is when we've got a straight line. So this is a, say for instance like that. Y is equal to, say, 5. We can see that the range here would only be 5, but that's the only special case for this. And I guess we can have a look at x is equal to something. So if I go x is equal to, let's say, positive 10, we can see that that's a special case as well. So this one here, we've got x is equal to 10 and 10 only. That's the range. So that's domain. And y is all reals. And we have here x is all reals and y is equal to 5. But for every other case, it's going to be that. X is all reals, y is all reals. What's our relationship and function? Well, we can see that there's only, for one x value, it produces one y value. Okay, so there's not multiple x values that produce the same y value in this case. Like x is 2, y is 2, x is 5, y is 5. There's no multiple y values coming out, and there's no multiple x values. Therefore, we say this is a function, and it's 1, 2, 1 for that reason. And if you want to think about it, this is like the x part and this is the y part. This is saying multiple x values, or in this case, one x value produces one y value, and one y value produces one x value. All right, so that's our linear function for this video. Let's have a look at quadratic functions. So what's our order? Well, we know that the order in this case, we've got y is equal to x squared, so the highest power is 2. Therefore, the order is 2. Let's have a look at the key features. We know that for y is equal to x squared, it goes through 0, 0, and it also has the point 1, 1, and also negative 1, 1. There's also a line of symmetry here. Line of symmetry at x is equal to 0. Okay, there's also this line here that you can just have a look at. So y is equal to 0. We can see that, and just waiting for it to load, we can see that the values won't go below y is equal to 0. Okay, so these are some key features you can use to help you sketch the quadratic function. So that's just loading up now. So let's look at the behavior. As x goes to positive infinity, well, we can see here as x goes to positive infinity, this is going to get, so x is 1, it goes 1, x is 5, we can see it's tending to infinity. So we go y goes to infinity and seems to be approaching it at a faster and faster rate. What happens when x goes to negative infinity? Well, we can see here when x goes to negative infinity, this graph is showing us that y is still going to positive infinity. And we can call this an even function because the order is 2, but even functions mean that for the negative and the positive, when x is approaching positive and negative infinity, the y is approaching the same direction. So an even function both goes the same way. Let's have a look at the domain. Well, x, is there any numbers you can throw into this that will break it? Y is equal to 2 squared, negative 2 squared, 100 squared, negative 100 squared. X can be any value in the domain. What about the range? Well, the range is a little trickier. We can see here that y, or the graph, doesn't exist below 0. So in this case, we say y is greater than 0. Is it also equal to 0? Well, if you look at that point, it does go to 0 as well, so 0, 0. Therefore, we say y is equal to or greater than 0. Now, let's have a look at it being either a function or a relationship. Our vertical line test says that it is a function because it only cuts it once. And is it many to one, one to many, etc.? Well, we can see that we have multiple x values producing the same y value. If I put x as 1 in, out comes y as 1. If I put x as negative 1 in, out comes y as 1. So we know it's going to be many for the x's. 2, and let's have a look at the y's. Well, y, if I put in a 5, I only get one x value out. Okay, so we can see this is going to be a many to one function. Okay, so there's not multiple x values. So multiple x values would look like this. I might have 2 values for 1, for instance. I might have x is 1, and then y1 comes out, and x is 1, y is negative 5, for instance. So if you want to think of the vertical line test, that's the way you can check. Onto the cubic functions, I think we've completed that. Key features, order, domain, I think so, yep. Let's have a look at this, the cubic function. So the cubic function, well, we know it's a polynomial still because it follows the form x to the n. Therefore, the order is 3 as the highest power is 3. Okay, what else do we have? Let's have a look at the key features of it. 1, 1, and negative 1, negative 1. Now, this is something called an odd function. And this means when x goes to infinity, we've got y going to, in this case, infinity. When x goes to a negative infinity in an odd function, because the order is odd, then it goes the other way. So see how these both don't go in the same direction, whereas an even function does. Now, we know that the linear function is also odd, so that means it should do the same thing. As x goes to infinity, y goes to infinity. As x goes to negative infinity, so does y goes to negative infinity. So odd functions have rotational symmetry, whereas even functions have symmetry over the y-axis. Okay, let's have a look at our domain. Well, we can see that x can still be anything. Negative 1 cubed, negative 100 cubed, 10 cubed, 100 cubed, doesn't matter. So x is all values. And we also see that y can be anything. So you may note for odd functions, y and x, they're pretty easy to do, aren't they? Y can be any value. So we've done that. Now let's do our vertical line test. Is this a function? Well, it only cuts it once at all places, so we can say it's a function using a vertical line test. And what else? Well, is it many to one, one to many, etc.? Well, we can see that is there multiple x values that create the same y value? Well, 1, you can see here, and you can sort of pretend it with horizontal lines, that there isn't any multiple y values made, whereas up here there is. So this is actually a one-to-one function. Okay. Now I'm going to stop the video here, and in the next video we'll be looking at reciprocal, square roots, and exponential functions. Okay.